behalf of the firefighting robot team, I'll be telling you a little bit about the competition and the project that we are involved in. First of all, our group is designing a small autonomous robot that will navigate a 2.5 meter square course, which is a small maze, to simulate a household environment. The robot will use sensor information and navigate throughout this course looking for a small candle flame. Once it finds the flame, it's going to extinguish the candle using CO2 or a water-based extinguishing method, and hopefully return to the original spot where it came from. Now we have about 3 months to complete the robot. We've started before the end of the junior year. We formed our group and did some research over the summer, and the past couple of months we've been beginning to design our robot, select components, and coordinate an overall design. So Everett and Aaron will be telling more about the design goals of the project.
We have a lot of really cool design ideas for this robot. The competition actually includes a number of challenges which really increase the difficulty but make it possible for us to really improve our score. To begin with, the robot's going to start in a random location in the maze. This makes it so that we can't just map out the maze and have the robot follow the same path every time. It's also going to be started with a sound signal, which could be something like a fire alarm. The sound signal will range between 3 and 4 kilohertz. The judge presses a button on the remote, the robot hears the sound, and it goes. In addition, the robot is going to have to deal with a dynamically changing maze. The door locations on each of the rooms will change from run to run. And we'll have furniture in the maze represented by 2-inch diameter steel pipes that we have to get around. Now when we reach the candle flame, we want to be putting it out with something that doesn't use oxygen. That means either carbon dioxide gas or water, because in real life you're not going to put out a house fire with a big fan. Now to give us a few more points on the more unique aspects of our robot, here's Everett.
Our team is implementing some design ideas that we think will give us the competitive edge in this competition. First of all, we're using a distributing processing paradigm, whereby we have a central gum sticks processor that is high-powered and is used for control applications, and then 2 HCS-12 microcontrollers that are doing sensor input and output. The team already has experience programming the HCS-12, so we think that will greatly speed development. Next, we're using a highly modular design by which the different electronic components of the robot are connected with standard headers. This will allow us to take different parts on and off the robot during development and for maintenance later on, making it easier to maintain the robot. Next, we're using laser range finding, something that hasn't been done before in robotics at Grove City College. We have actually 2 laser rangefinders on this robot. One, which will be front firing and very accurate, will only give us 1 data measurement that will allow us to establish an absolute position in the maze. The other will give us a range of data measurements across the front of a 90-degree field of view that will allow the robot to map out its environment and have a good idea of where it is in the maze, eliminating the need for dead reckoning. Next, we're going to be implementing dual opto-isolated power supplies. This means that one power supply will run the sensors and the microcontrollers, while the other will run the power supply, will be the power supply for the motors and the actuator for the extinguishing system. This will keep the inductive noise from the motors from influencing the sensor readouts and data that we need to navigate. Finally, in our chassis design, we are moving the wheels of the robot underneath to keep it from getting stuck in corners, and using high-quality Maxon motors with very good encoders so that we know where our wheels are at all times.
And now I'll pass it over to Peter and Tyler to explain how this will help customers.
It's not difficult to imagine some of the applications of this robot if it's scaled appropriately. There are 3 things in my mind that it could help do. One would be to protect human lives. The second would be to help aid the firefighters and maybe protect them from getting hurt. The third would be to protect the properties that the fires are started in. It would help save human lives because the robots are able to intelligently map the area and perhaps find the fires and maybe find the humans as well and get them out safely. It'd be able to protect firefighters' lives because potentially they would not have to go into the house in the first place. Thirdly, it could protect the property because if it was very effective at putting out the fires, then not as much of the property would be damaged. I'm now going to pass it off to Peter to talk about some of the sensor technology and marketing.
Well, despite all the advantages of having a life-size, functional-size firefighting robot, the fact of the matter is that technology doesn't exist yet. The goal of our project the way it contributes to having a functional firefighting robot is to develop underlying technologies that would be components of such a robot. Sensor technology, being able to detect flames and orient the robot towards them, something that could be incorporated in a functional firefighting robot and used to actually fight fires. Navigational techniques, being able to map out an unknown or known environment and move from place to place in that environment effectively. It's another thing that would be vital for a firefighting robot that might be stationed in a warehouse or in a home, or even taken along with firefighters to fires and sent into the building to locate the flame, locate people, and protect the firefighters from having to go into an unknown situation themselves. In short, all the benefits of firefighting robots depend on the underlying technologies being developed, and that's something that our project can contribute.
Now, you've seen the trends in technology. You've seen the benefits that our product can offer. Now, there's only one thing left to do. We'd like to ask you to please support our product financially to make this marketable to the masses.